I had a question about, a couple of people asked this actually, and this is about problem 2880. And so I wanted to go back and reference this. This is from lecture 13 on capacitors. And so we had a clicker question that said, so metal wires are attached to the terminals of a 3-volt battery. What is the potential difference between points 1 and 2? And what we talked about was that basically this is an example of a metal, which is a conductor, that will eventually be in electrostatic equilibrium. So when you hook this system up, all right, the electrons in that metal are free to move, and they're going to keep moving until they don't feel a potential difference. And so since there's a whole bunch of them, what that means is they're going to pretty much set this up so that this whole piece of metal becomes so again, this battery was 3 volts, so I just decided to call the bottom 0 volts and the top 3 volts. And so what that meant is all this piece here, every piece of metal here will be 3 volts, and then every piece of metal over here will be 0 volts. And again, the idea is, if this doesn't happen, then the electrons will move, right? Electrons are going to move if they sense a potential difference. And so if the whole thing is 3 volts, there's no difference, so there's no reason to move. And so this thing here is basically just a not very good capacitor. All right, so basically it starts out and the charge will accumulate, and so what happens is this end becomes 3 volts, that end becomes 0 volts, so it's a very analogous to a capacitor. And so in this problem here, it's the same idea. So the question the person was asking about was, I think they were trying to find, I think what they ultimately wanted to find was the potential difference across this capacitor. And so what happens is when you close the switch, charge will flow. Okay, so charge will flow in here, and basically, you're going to end up with a potential difference over here. But what'll end up happening is, this wire and this resistor are just pieces of metal. And so what will happen is this whole element here, this whole guy here, will end up with the exact same potential. If it doesn't, then electrons will still flow. So this whole thing will come up with the same potential, so whatever it happens to be, and this bottom part here will also come to the same potential. Now you can see that they're hooked up over here and hooked up over here. So every one of these circuits is a little bit different, but what this implies in this case is that the voltage drop across this capacitor should also be the voltage drop across this resistor, because this point is on the top of the resistor, this part is on the bottom, and so basically, all points here should have the same potential and the same thing down over here. And so in a case like this, in a sense, this 10 ohms is just kind of isn't really doing anything right now. Right, so a resistor with no current going through it is just a piece of metal, right? And so basically, when you do problems like this, what you want to do is you want to figure out, okay, let's go to the part of the circuit where there is a current flowing and figure the voltage drop there. Hope that helps.